So in this question, we're given a quadrilateral ABCD, and we're told it's a trapezoid. And we're given some side lengths. We're given AD is 15, AB is 50, BC is 20, and the altitude is 12. We want to know what is the area of the trapezoid. So the idea here is, again, we're going to focus on what the question is asking. So the question is asking, what is the area of the trapezoid? So if you have a trapezoid, then the area of the trapezoid is going to be like, it's the average of the bases times its height. Remember, if you have like a trapezoid of base B1 and the second base is B2 and the height is H, for example, then the area of the trapezoid is going to equal the average of the bases, so B1 plus B2 divided by 2 times the height H. So that's how you would calculate the area of a trapezoid. And we see in this question, there, like, it's very nice of them. They gave us AB 50, that's like base B1 basically. And they told us the height 12, so they basically told us H. So to find the area of the trapezoid, all we need now is this base B2. Or in the diagram, basically, what is the length CD? Once you find the length CD, we can essentially find what the area of this trapezoid is. So let's draw like a bigger diagram. So we have 15, 50, 20, 12. So 15, 50, 20, and we're given this height is 12. And I guess you could label them if you want, A, B, C, D. It doesn't really matter in this question. Okay, so to find what the length CD is like, okay, so I guess it's not really a misleading thing, but like one like thing that they did is they drew the altitude somewhere in the middle of the trapezoid. They drew like the height 12, like somewhere like in the middle where we don't get like much information about it. But like this height 12, like it should be like 12 like anywhere, right? Like it should be like 12 here, 12 here, like 12 here, like anywhere, like you can like kind of slide this like height like horizontally. The height should always be 12. So hopefully that made sense. That means we can just like kind of like draw the height like right here instead of like in the middle, because if you put the height in the middle, it's kind of hard to like work with it. So we can put the height here. So this, we know that the trapezoid has height 12. So this height is also 12. So notice that like this is going to be a rectangle. This thing, like let's call this like X and let's call this like Y, for example. Okay, yeah. And we know that quadrilateral AB XY is going to be a rectangle. So if AB has length 50, that tells us XY also has to have length 50. Now to find like if we want to find DC or CD or DC, then we need to find what the lengths DY and CX are. Once we find those, then it's pretty easy. And to find those, we can just kind of like do the Pythagorean theorem on like this green triangle here, for example. And if we were to use the Pythagorean theorem, we know the Pythagorean theorem tells us that the sum of the squares of the legs of the right triangle is equal to the square of the hypotenuse. So we would have 12 squared plus dy squared is equal to 15 squared. So 12 squared is 144 plus dy squared. 15 squared is 225. And if you subtract 144 on both sides, you get dy squared is 81. So dy is 9 by taking the square root of both sides. So we found dy, that's pretty good. Now we can find cx using a similar method. Now we can just use the Pythagorean theorem on this yellow triangle here. So we would just say 12 squared plus cx squared is 20 squared. Because, 12 squared plus cx squared, 12 is the leg, cx is also a leg, 20 is the hypotenuse. So 12 squared plus cx squared is 20 squared. So this is 144. This is 400. So 144 plus cx squared is equal to 400. So you get cx squared is going to equal 400 minus 144, which is equal to 256. And now we can take the square root of both sides. The square root of 256 is 16. So we get that cx has length 16. So we can replace this length with 16. And now we can find what the length of CD is, this entire length, by just adding up 9 plus 50 plus 16. So CD is 9 plus 50 plus 16, which is 75. And now we have the other base of the trapezoid. So to find the area, we just take the average of the bases times the height. So I'll just do it here. The area is going to be equal to, remember, you take the bases, you add them together, you divide by 2, and you multiply by the height, so times 12. So 50 plus 75 is 125, divided by 2 times 12, that's basically times 6. So 125 times 6, that would give you 750. And that would be choice D.